Welcome to another episode on my Arduino Mega2560, connected to Arduino Uno by means of SPI as well as I2C. Also connected to a breadboard with electronics and some fischertechnik mechatronics. Last time I tried to get the motor on the right hand side to work. One is still not doing what it should do, while one other is this one doesn't do anything for now. This one has not a problem because while it theoretically works, it has a problem with getting to work here and working here. So I figure that I have to check this out for a moment. Alright, two-handed might work. Nope. You will always see that when you want to demonstrate something, it doesn't really work. And a big probe here doesn't help. So let me remove it. This makes things a bit clearer. So, does it work here? Right now, answer is no. And last time it did work here, so let me try once again. Yeah, now you can see that it works. And that is exactly what is supposed to happen. Now here, on the other hand, I can wait, but it doesn't work. And then I can do it here, and it doesn't work either. Yet last time I checked the wiring and things were measured to be alright. So once again, making sure that the wire is correct. And it would be nice if the motor started working. Yeah, it gives a hint, yes. So I need to figure out what is the difference between this circuit and that circuit, which is apart from this difference, of course, with some inductors. Because this used to work, and then I'm talking about early episodes in this series. So yeah, I want to get it back to work again. And that means also that I need to check on signals with an oscilloscope. And since I can do that best using on-screen camera, I'll change to screencast and show you there. Alright, so right now it is shown the Mega2560 Uno oscilloscope camera and circuit camera. I'm going to change that. I'm not talking about, well, yeah, let me do it slightly different. This is showing that I2C works. This is also shown that everything works. So in that respect, this can go out, down, this can go down, this goes here, and let me do it this way. So maybe something with the lighting. Alright. So what's the point? I have a circuit right here. Or more properly right here. And I have a circuit right here, and they should do the same, I think. Let me exactly figure out where goes what. And that means that this blue wire goes straight to 7. So, and that is output 7, this one. Yeah. And this one. Alright, hold it here. Output 7, 253. That's one. The other one being and I have to take the upper green wire, which goes with the blue, which is in pin 2. So I need to verify with pin 2, which is propeller 250. So they are exactly the same in value. Do they measure the same? That I will have to check. So yeah, do I check behind or before the transistor? Let me check before. This doesn't show anything. I have to reposition myself a bit. So let me do it slightly different. I put this one right here. This is basically in front, which is strange, because this would mean there's no signal at all. And it does work, so that's a bit odd. Let me then measure here. So this is quite odd. If things do work, then how come I get hardly any signal? Alright, other one. And this one I put once again, if it works. This one should go into the plus, and that's the problem. I think I make a mistake in wiring right now. Red should go in red. So this one I need to put wired and all. I should put in here. That's one thing. And it is this wire that I have to change. So let me take this one out and put here, if the wire allows me. And right now that's a bit of a problem. And with the camera towards the motor, there's no chance of it going anywhere, of doing anything. Right now let me take the third probe, activating it. And putting it somehow up to the circuit. It could be here. Now this is a signal that I like to see. And this is strange. So when the motor, when this motor gets a hiccup, this one becomes active and this one doesn't. So how does that happen? And in the meantime they both have the values. 250 right now, 252. So the output is alright. Algorithm then? No, because then they would change in here as well. So how does this work? Okay, that's a plus. Just goes on the same. What is with this signal anyway? Very, very strange. Can't explain yet. I have been watching the signals right on the scope, and what is remarkable that with the probe here, here and here, so this one is going, now I have to say this correctly, to this motor. This one is going to this motor, and this one or going to, it's observing this motor. Now you see here a plus or minus going by, which is not completely synchronous with hitting the switch here. So why that is, not quite sure. Then when this one is shortly with pulse modulated signal, this one vanishes. Now it's also remarkable that this one is twice as high as this one, the value. Although that is not entirely true, but it is number 4. So let's see 4 and look at 4. Where do you go to? Where do you come from? Again, exactly the same signal. So is this because of an SPI delay? Is this because of an I2C delay, or both? Well, everything is delaying something now. But this I find quite remarkable. Well, what I can do, of course, this one, is checking if the plus here corresponds with like this. And this is then I2C or SPI. No. Oh wait, I have to do it like this. So let's see what happens when. There's a high plus and they both go away. And it looks like that is I2C, but I2C happens a lot, and this interruption doesn't happen a lot. And SPI isn't corresponding to the plus either. I2C seems to be. So let's wait if that is indeed the case. Yeah, looks like I2C makes it happen. So let's wait and see and detect again. Yeah, it's I2C that makes it happen. Right. But the point is, that's remarkable. Something in the code is happening prior to, which signal is it? It is signal from 7. So let's see about that one. Where does it happen? Yeah, right here, 7. And looking here, it's 7, 2 and 4. Well, 2 and 4 don't occur here, but they do occur here. So yeah, if the value big 9 is high or low, how do I see that? Oh, and that was a problem in the past as well, that it has to be timing. Oh, here, propeller. So then it is low, and the digital 9 high. When is it high? It is low, of course, and then for digital high. Then both should be low. And still low here. And that is a matter of timing. and high is much less frequent, of course, unless I force it with my hand, which I've done before, just to see how that happens. So let's take a screwdriver and hold it right here. Does it really matter? Is that really the case? I press it constant and yet I don't see it. This takes more than just a short experiment. But still the question is, how can I change this? Then I will have to change the algorithm. But how? And then another point is that this measurement started with the observation that when I wire this one over here, that it does work, but not every time. Well, if I look at it now, it's no chance of working. So let me do that for a moment once again, and yet there it does. There it goes. So that's a strange thing. Although apparently no signal, there is pulse modulation because it works. So let me remove this and put it right here. What do I get to see? A full signal of pulse modulation. Let me adjust the time base. And it stops as well. So it starts and it stops. But it is a full signal here. But it's not on the line. Because on the line is here. So why does it happen then? And that is a very good question. And I don't know. Not right now. Alright. Let's put it here again. And it's a full signal. And yet the motor doesn't always work. So-called very strange effects. And then I also noticed that this isn't working anymore. So why does this motor stop now? I hear a motor whine. But the why and the how, it has stopped completely. Ah, right, position of the transistor. Is that the same here? Or here? Not as far as I can see. Anyway, instead of solutions, more riddles. But how to solve them. So, instead of solutions, I found more riddles. Transistor signals, pulse modulation, wiring, and why is a plus signal directly correspondent to I square C? Or more appropriate, the timing of I square C in the whole algorithm of the Arduino Mega 2560. So observation goes before correction, so I hope next time that I can make some corrections. Maybe disable I square C and SPI altogether. Who knows? Anyway, I hope I can go on with this and find out why. For now, thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Also leave a comment, please. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. You can show your support if you like all this by making a small donation. Very much appreciated. You can also become a patron and have your name mentioned, depending on the pledge you make, either just on my website or on my website and with my video. And all voluntary, of course, but very much appreciated. For now, thank you for watching and bye bye.